Okay, moving on as we get ready to solve quadratic equations. Some of the equations you're going to solve will not have any real number solutions. We might get something like this, square root of negative 17. And that doesn't make any sense because there are no numbers times themselves that equal a negative number. A negative times a negative is positive, and a positive times a positive is also positive. You're never going to get the same number times itself equal to a negative number. So mathematicians really needed to solve that problem because they needed to work with some of these quadratic solutions that had a negative number under the square root sign. So they actually invented an imaginary number, and that imaginary number is called I, and it's lowercase I. And what I is it's the square root of negative 1. So we can answer the question then, what number times itself equals negative 1? Well, I times I equals negative 1, or I squared equals negative 1. The solution to the square root of negative 1, it's not a real number, but it does now exist. It was invented for a purpose. Since the 17th century, I has actually become useful for many real-life things. You can use it for calculating electrical circuit problems, quantum physics, and many other science fields depend upon I. So there's two things you need to remember as we move on, and that is that this imaginary number I times itself, or squared, is equal to negative 1. So therefore, if you're asked what the square root of negative 1 is, it's I. And here's where it becomes useful. I'm going to skip down to the problem first and then come back to the general form. If I want to find the square root of negative 75, I can rewrite it like this. The square root of negative 1 times 75. Wouldn't you agree that that result will make negative 75? And any products or quotients under a square root sign can be split apart. So I can split this apart into the square root of negative 1 times the square root of 75. Now, since mathematicians have come up with the imaginary number for us, we know that the square root of negative 1 is this funny little number, I. So this part becomes I, and then we can calculate the square root of 75. So I grab my calculator, square root, put in the 75, oops, gotta turn it on, second square root, got my square root sign ready, close my parentheses, and I get approximately 8.660. 8.660. So the square root of 75 part makes this. So now we have I, which is our imaginary number, that's the square root of negative 1, times this numeral, and then we usually just rewrite it with the number first and I following, just like when we write variable expressions. So if you would try a couple more on your own, go ahead and do the square root of negative 81, the square root of negative, how about negative 28? Go ahead and try those two. Pause the video for a moment. The first one you shouldn't need a calculator for. Alright, coming back. Did you say that the square root of negative 81 is the square root of negative 1 times the square root of 81? And then, let me grab another sheet of paper here. Did you say that that is I times 9, since the square root of 81 is 9, and then rewrite it as 9I. Square root of negative 28, let's do it this way this time, square root of 28 times the square root of negative 1. And I grab my calculator for the square root of 28, should be 5 point something. Second square root, put in 28, and I get about 5.292 if I round that 1 up because of the 5 following. So 5.292 I following it. Alright, so in general, if we have the square root of a negative number, we can break it apart into -1 times the absolute value of that number, and the final answer will become I times the square root of that number. And then of course we're going to want to rewrite it with that answer, whatever the square root of that is, with I following it. We'll put parentheses around that. And that's it.